All right, here we go. 11-4. Now listen, you want to pay attention to this. It's not real difficult, but the formula is actually very simple. But it's almost deceivingly simple. Okay? This is a polygon. And so what we're going to do is we're going to try to find the area, not just of any polygon, but of a regular, let's try to make that look better, okay, of a regular polygon. We know what a regular polygon is. We've had a whole lesson about regular polygons. We've found angles and all that other kind of stuff with regular polygons. So just to review, what is a regular polygon? What's true about all the sides of a regular polygon? They're all equal to each other, exactly right. They're all equal to each other. What's true about all the interior angles of a regular polygon? They're all equal to each other, aren't they? So if it's a regular polygon, all that stuff is true. All the sides are equal, all the angles are equal. Everybody got that? So what we're going to do right here is only works for the area of a regular polygon. Let me show you the equation, or the formula I should say, and then let me explain what one of the things is. One of them you'll know exactly what I'm talking about. The other one I'll have to explain to you. So here it is. Area, this is area of a regular polygon, is equal to 1/2. There's that 1/2 again. That shows up a lot, doesn't it? 0.5. So don't forget to put the 1/2 in front of it. Now, this is the one part that we haven't talked about. We'll talk about in just a few seconds. It's little a. Little a stands for this, apothegm. A-P-O-T-H-E-M. It is kind of a cool word, okay? Apothegm. Yes, that's in our formula. Yeah, it's in our formula. I would hope you would want to know it. So it's 1/2 the apothegm times the perimeter, and that's it.
What's apothegm mean?
I'll show you. I said in a few seconds I'll let you know. I know it's very exciting, but just be patient. Be patient. Apothegm, not a possum. Apothegm. All right. All right. So here's the apothegm. Now, let me show you. This right here. Shh, listen. No, it's not like theta. It's just a little letter A. It's just a regular old A. All right. But here's what it is. See this dot right here? This dot is in the center of this polygon. 1, 2, 3, 4, 5. It's got 5 sides. It's a pentagon. Okay. Now this works with any polygon. All right. We'll do it with a couple of these, but this just happens to be a pentagon. Now watch very carefully. This is the center of the polygon. All right. This dot right here. If I went perpendicular to one of the sides. Now listen very carefully, because I'm telling you for the first time what the apothegm is, and you're going to want to know. If I start at the center and I draw a line or line segment perpendicular to one of the sides, you follow me? That right there is the apothegm. So if I can find that length right there and I can find the perimeter, all I got to do is multiply those three things together, 1/2 the apothegm, the perimeter, and then I've got the area of this whole thing right here. It's got to be perpendicular. Now look, that's not the only apothegm in this whole picture, is it? The apothegm, yeah, you could think of it as the altitude, right? All right, so look, right here, that would be an apothegm as well, wouldn't it? All right, then I can draw another one. I could draw another one here if they're perpendicular. That would be an apothegm, that would be an apothegm, and that would be an apothegm. Wouldn't you agree? It's actually Chrysler. Yeah, it looks like a Chrysler symbol, but I'm going to show you another one. So that's the apothegm. Everybody with me on that?
Yes.
Yes? Okay. So that's how we find the area. Now watch. If they told you the apothegm, and that would be really nice if they told you the apothegm and the perimeter, or even one of the sides. I'm going to make this as easy as I possibly can make it. Everybody watching? A lot of people looking around. Let's look up here. I'm going to make this as easy as I possibly could. All right? It's rare that you're going to see a problem this easy, though, in the worksheet or in the quiz or test or whatever we're going to take. Let's just make up a number. I'm just making this up off the top of my head. Let's say the apothegm is 3, and let's say from let's give you the whole side. We'll make it super easy. Let's say this was, I don't know, 7. Okay? Everybody watching? Tell you what, let's keep it like that. So that's 7 right there. And I asked you to find the area of this polygon. Now, there won't be too many that are going to be this easy. All right? I'm just warning you right now. So it's 1/2 times the apothegm, which is 3, times the perimeter. This is the only thing you really have to think about on this particular problem. Is it just times 7?
No.
No.
Times 4.
Is it 4? Is that 4 sides?
It's 5.
5.
35.
1, 2, 3, 4, 5. That's right. So the perimeter would be what? 7 times
35.
5, wouldn't it? Which is
35.
35. And so I can put a 35 right here. All right? You can put that in a calculator, whatever that comes out
Actually, in my
to.
head, 3 times 5 is 15 times 5. 3 times 3.
52.5.
52.5?
Yeah.
Okay, thanks. Because I don't have the calculator up and ready.
Way to go, Kelly. Thanks.
You're welcome.
All right, that's the area of this thing right here. That's not that big of a deal, is it? That was pretty fun. Now look, what did I say though? This is about as easy as it gets. Okay, now they could have told you the whole perimeter. All right, that would have been super easy. That wouldn't have been a challenge at all. Okay, at least they just told you one side and you had to find the perimeter. Here's what they're going to give you though. They're going to give you a couple things, and let's do the same figure. We'll still do a. I tell you what, let's do a hexagon. A hexagon's actually a little easier. Let me find a hexagon here, and we'll do an example with a hexagon. All right, so that's a hexagon. We'll drop it down. This one's a little bit more involved, but it's not beyond your capabilities, though. We just finished a chapter on right triangles, and we did like sine, cosine, tangent, and all that, 30, 60, 90, 45, 45, 90. Remember all that stuff? All that stuff's going to come into play here, so hopefully you didn't forget it, or
12, 13.
hopefully you learned it in the first place, okay? All right. Kenny.
I'm sorry.
Let me find an example.
Can I do better?
Here's what they tell you. Just watch this problem. Be strong.
My iron bladder.
Okay. Watch this. They tell you the length of this side, I believe. Find the area regular hexagon. Yep, they tell you the length of this side. This is all they tell you. Okay? It's the only thing they tell you. Now, I'm not going to expect you to be able to do this right now. But follow me step by step. Write it down. All right, so that you go back and you look at it and it's written down right in front of you. Even if you do look at the video later, at least it's right in front of you. Let's write the formula down. Now, this is how many sides? 1, 2, 3, 4, 5, 6. Okay, so the area is still what? 1/2 the apothem times the perimeter. All right? Kenny already said it. The perimeter is the easiest part to do, isn't it? Because if I give you one side, we already did this in the other one. So let's do the perimeter right now. So the perimeter would be what? 3 times 6, right? Why 6? Because there's 6 sides, right? So that's 18. So far, that's basically half of what we have to do, isn't it? All right? So what do we really have to find, though? The apothem. That part's not quite so easy, all right? But I'll show you how to do it, and you're going to look at it, hopefully, and say, you know, that wasn't so bad. I hope you say that. Watch what we're going to do. Let me show you a little trick here. It's not really a trick, but it's how you do it. So watch what I'm going to do. I'm going to draw a line here. I'm going to draw a line right here. Now watch. If I'm not going, I'll erase some of these. You don't have to draw all of these. This is just for teaching purposes. Watch this. It's a bunch of triangles. How many triangles?
6.
There's 6 of them. Now look at what I'm concerned about is this angle right here. And you're probably thinking, why in the world do I care about an angle? I'm just trying to find the length of a side. I don't even see the apothem on here anyway. I'll show you, okay? You'll need to know this angle. So how in the world could I find this angle? No.
Why would you use a protractor?
That's right. Christian, what'd you say? Say it again. Listen to him. 360 divided by 6. Why 360?
Oh, I know the answer. I know.
Because if I went all the way around, that makes a full circle. That's 360 degrees, isn't it? How many angles do I have? 1, 2, 3, 4, 5, 6. They're all exactly the same because it's a regular polygon. So how do I find that one angle right there? I take 360 and divide it by how many angles that I have, which is 6. And what does that come out to be? 60 degrees. All right? So let's get rid of this big old circle thingy here. And actually, I can get rid of this. Do you see why I put all those lines in there? To show you that there are 6 triangles in there. But I'm just concerned about that one angle right there. Now, why do I care about that one angle right there? I'll show you. I don't even have something drawn that I really need to draw. What is it? The apothem, right? So let's draw the apothem. It goes from the center, where?
Perpendicular to the
Perpendicular to one of the sides. Yeah, to one of the sides, okay? So that, right there, that pink one is the apothem. That's what I'm trying to find. Now, do you see why I found that angle?
No.
You
The opossum's not 60, then I don't see why.
But look, what's that whole big angle?
60.
What do you think this little one right here is? This is 30. Okay, listen. Listen. I know this is exciting stuff, but you gotta settle down. All right, listen. Shh, come on, you're wasting my time. You're wasting my time. Listen. Look, this whole angle right here is 60 degrees. These two are equal to each other, so we had something a long time ago that said when we draw a perpendicular line from here on an isosceles triangle, it splits this angle in half. Okay, so just know that it splits it in half. It also splits this side in half as well. Okay. That apothem does. The apothem splits two things in half. Splits the angle in half. So it was 60, wasn't it? So now that one's 30 because we split it in half. All right. So if that's 90, what's this angle down here at the bottom? That's 60, isn't it? Let's talk about the side now. That whole thing is 3, isn't it? What is it from? Yeah. What is it from here to here?
Well, let me get my calculator.
It's one calculator for half of 3. It's 1.5. Now look, all that stuff was needed, listen, all that stuff was needed to find the apothem. Now, you could find the apothem a couple different ways. You could use a trig function. You could use this angle up here and say what? Opposite over, no, this is not hypotenuse. What is this? Adjacent.
Whatever.
So you could use opposite over adjacent, couldn't you? All right? You could do that. Or, it's a 30, 60, 90. What do we know? Listen. This makes it easy, and this is why it's nice. Scrap, we got into this every once in a while. This is where it's really nice to know those rules for 30, 60, 90. This is the short side, isn't it? So this is the long side. What's the relationship between the long side and the short side?
Square root of 3.
That's right. So this long side right here is what?
Square root of 3.
Yeah, it's 1.5 times the square root of 3. It's not just the square root of 3. It's the short side times the square root of 3. That's the apothem. That's what I needed to know, isn't it? So now I'm ready to find the area. It's 1/2 times the apothem, which is what? 1.5 times the square root of 3. Let me finish first, and then we'll answer questions. And then times the perimeter, which is 18. Chuck all that in your calculator, and you got the area of that thing right there. Okay, you said wait.
So does the apothem have like its own formula?
No, you just got to figure it out. This just happens to be a 30, 60, 90 because 360 divided by 6 was 60, right? So that whole angle was 60. Agreed?
Yes.
So that whole thing is 60. And, yeah, so you could have used a trig function. What if this didn't come out to 30 and you didn't have a 30, 60, 90? You couldn't say, oh, that's the long side, so it's always a square root of 3 times the short side. All right? You might have to use a trig function. And we'll do one here in a second that you might have to use a trig
I have
function.
your answer for
Okay.
you.
Okay, what is this?
23.38.
Okay, round it to a tenth.
So 23.4.
Good. All right, and let's say it was in meters, so it's meters squared. That's area. So that would be the area of this whole entire hexagon. All right, that's how you find it.
Because it's the long side.
Because the long side, remember, I just went back to what I learned before. The long side is the square root of 3 times the short side. That just made it easy. Don't you agree that made it easy? Watch this. Kayla, you've got your calculator, right? What's 1.5 times the square root of 3? Don't do all the other stuff. Just what's 1.5 times the square root of 3?
Okay. 1.5 times
The square root of 3.
2.6.
Okay, 2.6. Let's just hang on to that. So the apothem is around 2.6. Look, you could have done this another way. You could have done a trig function if you wanted to. You could have used this angle 60. You could have used this angle 30. Which one would you want to use? Doesn't make any difference. Let's use the 30, okay? So watch. Let's use the 30. This is opposite and this is adjacent, correct? So that's tangent. Watch. The tangent of 30 is equal to the opposite divided by the adjacent. Agreed? So let's solve for A. Kayla, you ready?
Yeah, what?
It's 1.5 divided by the tangent of 30. Kenny, go before you go all over the floor, for goodness sakes. Take a pass. Take a pass. You sure?
Well, it's actually 2.59, but I rounded it to 2.3.
2.59 and you rounded it to 2.3? How about 2.6?
Oh, that's what I meant.
That's what I thought.
Yeah.
Okay.
Or you
Look.
just round it to 3.
Look, the apothem doing it,
3.
you know, with the 30, 60, 90 was 2.6. Using a trig function, look, the apothem was the same thing, right? So you could have done it either way, couldn't you? All right?
Could you just round that to 3?
No, because it says round the nearest tenth, so we'll round to the nearest tenth.
That's what I meant.
Okay, so you could do it either way. So don't think that you always are going to use a 30, 60, 90 on these, because if it's not 30, 60, 90, you're going to have to use a trig function. All right, so you're going to have to rely on stuff that you learned in the other chapter to be able to do this. For some of you, that's not a big deal because you didn't have a problem with that. For some of you, like, oh my gosh, I got to learn it for once, okay? I already had a test on it, but I'm going to learn it again, okay? Let's do another one, okay? Let's use this. Let's use this. What's that? Now look, it took me a long time just because I sat here and explained every single little step, okay? It's not going to take you near that long to be able to do this, all right? But you're going to have to practice it. You're going to have to go back and watch this YouTube video again. Watch it 2 or 3 times. Pause it, go back. Pause it, go back. Write stuff down until you understand what's going on. Now look, let's give the same information. Let's do the same exact problem, except this is not a hexagon. It's a what? It's a pentagon. So let's do this. So let's use a different number. Let's say that's, I don't know, 10. All right? So here we go. You're watching? So look what I'm going to do. This is what they give us. They give us a pentagon. They say one of the sides is 10. That's all they tell you. It's the only thing they tell you. And you're going to be able to find the area of this pentagon. All right? So let's write down the formula first. I always write down the formula first thing. 1/2 apothem perimeter. You got it? What can you find super easy right now without hardly thinking? The perimeter. So it's what? It's 10 times, how many sides in this one? 5. So 10 times 5 is 50. So we got the perimeter already. So what do we really have to work for? The apothem. All right, so let's find the apothem. Let's draw the apothem first. I'll make it blue this time. So there's the apothem. That's what we're trying to find. Everybody see that? All right. So what do we do though? We got to draw a couple other things in there. Do you remember what we drew? From here, the triangle. From here to here, and we're going to draw from here to here. Now, what's the one thing that we can find knowing that we have a triangle here?
You can find, wait, no, never mind.
Remember, we're trying to find A, the apothem. Okay? So what can we find? I'll give you a big hint. It's this. We can find the angle. How do we find that angle right there? So it's 360 divided by what? It's not 6 this time, is it? It's 5 because there's 5 sides. Remember how we drew those lines and we had triangles? There would be 5 triangles in this one. So we take 360 divided by 5. Kaylee, give me a number.
50.8.
Kaylee, give me a number. 360 divided by 5.
72.
Divided by 5, 72.
72? Okay, good.
Any regular polygon you divide by 360.
That's well. No, don't divide by 360. You take 360 and you divide it by how many angles you have. Well, it's not the same thing. So I just make sure we say the right thing.
All around, it's always going to be 360.
Yeah,
right?
exactly. Because if I drew here, here, and here, the whole thing would make a circle. So that's why I use 360. There's 5 different triangles. That's right. How many triangles you have, which would be 5 of them, right? Or how many angles? Would be 5 of them. And so that's why I divided by 5. So that whole angle is 72. But I'm not really looking for that whole angle. That's right. I got to find this angle, which is 36. How did I do that? Split it in half. Now look, I know this angle. Shh, it's too much talking, okay? There's no way you should be talking this much for this. This is not that easy where you guys can just blow me off and just talk to each other. It's impossible. Let's pay attention. We only got like a minute left. And we can do this. Look, that's 36 right here. Let's find this little side right here to the triangle. That's super easy. The whole thing was 10. This is half of it, and that's 5. Now look what we can use. We could find this angle down here if we wanted to, but let's just stick with this angle. Look what we can use. Opposite, adjacent. That's tangent. So it's the tangent of 36 equals the opposite, which is 5, over the adjacent. I got to finish. You're going to have to look back on it. Let's not worry about that. Let's just use this angle right here. Look, solve for A. So we switch places. You remember the algebra. Over the tangent of 36 Need a calculator person now. 5 divided by the tangent of 36.
Come on, hurry up, hurry up, hurry up.
Kenny, stop.
Sorry.
6.9.
6.9? Okay. Alright, so that's our apothem. We're basically done now, aren't we? We just have to multiply the stuff together. So it's 1/2 times the apothem, which is 6.9, times the perimeter, and we already found the perimeter earlier, which was 50. Throw all that into a calculator, and you get...
Hold up. 1/2.
Bye.
Just hit 25. No, don't buy yet. Go 25 times 172.
172.5.
Okay. And that would be your area right there. Now look, you're going to have to go back and watch these videos and take it step by step. Yeah, I got a worksheet for you. Don't leave before you get the worksheet.